Um, Imagine for a second that you're stepping into this, like, sweltering, soot-stained 19th century workshop.
Okay, setting the scene.
Yeah, it's 1879, and you are watching this glass blower painstakingly craft a delicate glass bulb for Thomas Edison's very first commercially viable incandescent light.
Wow.
You know, you could practically smell them burning coal, feel the intense heat radiating from the furnace.
Right, right. Now, I want you to hold that thought, and let's fast forward to the year 2026.
Okay, zooming ahead.
You are standing inside a hyper-modern, glowing blue, completely sterile server farm.
Oh, total contrast.
Completely. There's this deafening hum all around you, right? And that sound is artificial intelligence processing, I mean, literally trillions of calculations per second.
Which is just, it's hard to even wrap your head around.
It is. It feels like an entirely different universe, completely disconnected from that 19th century workshop you just described.
But here is the paradox we are exploring today, and welcome to this deep dive, by the way.
Yes, welcome.
The exact same company that made the glass for Edison's light bulb is currently the secret bottleneck and really the ultimate enabler of the 21st century AI revolution.
It's kind of mind-blowing when you put it like that.
It really is.
Yeah.
So our mission today is to connect these seemingly impossible dots. We're looking at a pretty fascinating stack of source material today.
We are, yeah.
We're starting with a very aggressive 2026 investment thesis, and this is focused on Corning Incorporated, ticker symbol GLW.
Right, the glass guys.
Exactly. And the thesis predicts a massive financial upside for this legacy glass manufacturer. But we are pairing that financial analysis with this highly technical engineering excerpt.
Which gets pretty deep into the weeds.
Oh, it really does. It's about a microscopic breakthrough called through-glass via, or TGV technology.
Right. And if we connect this to the bigger picture, we tend to think of the internet, the cloud, and AI as, I don't know, ethereal, right?
Yeah, totally. Like it's just floating up there.
Exactly. We use words like wireless and cloud computing. It sounds like magic. It sounds like software living in the sky.
But it's not.
No. The reality is starkly physical. I mean, the internet is not made of air. It is literally made of sand, silica, and glass.
Yeah.
And to understand why tech hyperscalers, the massive behemoths like Amazon, Meta, and Google, who operate at such a crazy scale, they essentially dictate global supply chains.
Right.
To understand why they're throwing billions of dollars at a 170-year-old glass manufacturer, we really have to look at the physical limitations of computing.
Okay, let's unpack this. Because, to understand why Corning is essential to modern AI, we first have to figure out how a company survives since 1851 without becoming completely obsolete.
Which is a feat in itself.
It really is. Think about all the industrial giants of the 1800s.
Most of them are dust.
Literally gone. But Corning evolved from Edison's bulbs to just total dominance in material science. When you look at their financials and the source material, they aren't relying on a single miracle product to keep the lights on.
No, not at all.
They have these deeply interlocked revenue streams.
Yeah, their survival is basically a masterclass in applying foundational science to diverse industries.
Right.
So like optical communications, which is the physical fiber optic cables and hardware for data centers. That's their biggest segment. It makes up roughly 38 to 42% of their revenue.
Which is huge.
It is. But then you have display, which creates specialty glass substrates for LCD screens on TVs and laptops.
Oh.
And that brings in another 23 to 25%. Then they also have an automotive division at 11 to 12%.
Wait, automotive? Like for cars?
Yeah. They engineer ceramic substrates that can survive the extreme heat of car emissions systems.
Oh, wow. I wouldn't have guessed that.
And if you are listening to us on a smartphone right now, there's a very good chance you are physically touching Corning's specialty materials division.
That brings in, what, another chunk?
Yeah, about 13 to 15%. I mean, Ceramic Shield, Gorilla Glass, that's all them.
Yeah. The thing that really jumps out from the financial analysis is the underlying engine driving all these divisions, right?
The R&D.
Exactly. The numbers show they operate as the unquestioned kings of research and development.
Oh, without a doubt.
Like in the manufacturing sector, the industry average for reinvesting revenue back into R&D is a meager 3%.
Just 3%.
Yeah. But Corning consistently pumps 8 to 9% of its revenue straight back into the lab.
That kind of patient capital is incredibly rare these days.
It really is.
They are essentially funding a massive ongoing physics experiment. And because they are working with the same fundamental materials, silica, glass, ceramics, A breakthrough in one division often solves a crisis in another.
That makes a lot of sense.
Right. Like the institutional knowledge they gained by figuring out how to make Gorilla Glass withstand a drop on a concrete sidewalk.
Yeah, we've all tested that one by accident.
Exactly. That knowledge directly informs how they manufacture glass that can survive the crazy manufacturing process of a microchip.
Which leads me to how I've been thinking about them.
Oh, yeah.
Yeah, I like to picture Corning as an infrastructure chameleon
Oh, I like that.
because they don't place massive, risky bets on which specific consumer product is going to win the market, you know?
Right. They don't care who wins the console war or whatever.
Exactly. They don't care if you buy a Samsung or an Apple device. They just become the skin, the skeleton, the literal infrastructure of whatever technological era we happen to be in.
Yeah, perfectly said.
During the dot-com boom, their fiber optics were the central nervous system making the web possible. During the mobile revolution, their glass was the face of smartphones.
Right. And to ground your chameleon analogy in hard numbers, consider their ongoing relationship with Apple.
Okay.
The financial analysis highlights this arrangement where Apple invested $2.5 billion into Corning's advanced manufacturing.
Billion with a B.
Billion with a B. And
Yeah.
the result of that investment is that 100% of the cover glass for iPhones and Apple Watches is manufactured in a Corning facility down in Kentucky.
That is wild, 100%.
Yeah. By securing that level of absolute market capture, they just create a fortress of incredibly stable cash flow.
Which brings us to a really tricky question.
Okay, lay it on me.
We're talking about AI infrastructure today, right?
Yeah.
Which is notoriously expensive and, frankly, highly volatile.
Oh, super volatile.
So how does a legacy company afford to invest billions in unproven next-generation AI architecture without risking bankruptcy if the whole AI bubble bursts?
That is the big question.
Because we've seen tech bubbles pop before. It wasn't that long ago that the telecom bubble burst and fiber optic companies went completely under.
Yeah, and this raises an important question about risk management in the tech sector. Corning's CEO, Wendell Weeks, actually addresses this directly in the corporate materials.
What does he say?
He states very simply, quote, "We're built to withstand bad weather."
Bad weather.
Right. And bad weather in this context means a total collapse in tech capital expenditures.
So how do they survive that?
Their strategy for surviving that weather is a financial framework they call the anchor customer model.
So what does that actually work out to be in practice?
Well, Edward A. Schlesinger, who is Corning's CFO, lays out the mechanism pretty clearly.
Okay.
He says, and I quote, "Either someone's co-investing with us, or they're committing to take the revenue, or even better, both of those aspects."
Oh, I see.
Yeah, in short, Corning does not break ground on a massive new factory hoping the customers will show up eventually.
Right. They force the tech giants to pay for the factory before a single shovel hits the dirt.
Exactly.
It's like forcing your roommate to pay their half of the rent for the entire year before you even sign the lease on the apartment.
That is a perfect way to put it.
Let's look at the real-world application of this, because the scale and the sources is just wild.
Oh, it's massive.
The sources detail an expansion of their optical cable manufacturing plant in Hickory, North Carolina. We are talking about a roughly $268 million investment.
Huge money.
Yeah, and it's going to create 15 to 20% employment growth in the area. Once this is done, this Hickory facility won't just be big, it will be the largest fiber optic plant in the entire world.
Let that sink in. The largest in the world.
And who is footing the bill to guarantee that expansion? Meta. Mark Zuckerberg's company made a staggering $6 billion commitment through 2030 to secure optical fiber and cable.
And they apply this model across their entire business, not just fiber.
Where else?
Even in their solar division. The financial data notes that over 80% of their polysilicon and wafer capacity is already locked in by non-cancelable commitments for the next 5 years.
Okay, I have to push back a little here, though.
Go for it.
We're analyzing a buy recommendation from an investment thesis that is painting a very, very rosy picture. Right?
Fair point.
Isn't relying on a few massive hyperscalers like Meta a colossal vulnerability?
It's a risk, certainly.
I mean, what if Meta suddenly pivots? The tech landscape changes overnight. If Meta decides next quarter that AI models are getting too expensive to train and they slash their capital expenditures by half,
Yeah.
doesn't that leave Corning holding the bag on the biggest fiber optic plant in the world with no one to buy the cables?
It is a completely valid concern. I mean, if you look back at the telecom crash of 2000, 2001,
Yeah, that was a bloodbath.
It was. Telecom companies laid millions of miles of fiber optic cable based on projected internet demand that just didn't materialize fast enough. Companies went bankrupt overnight.
Exactly my point.
And if Corning were only relying on Meta, it would be a severe vulnerability. But if we zoom out, the current infrastructure build-out is far more distributed.
Okay, how so?
Well, the total capital expenditure projected to be deployed globally in data center infrastructure through 2030 is $6.7 trillion.
Trillion.
And out of that 6.7 trillion, Corning's specific product lines expose them to a projected 5.7 trillion of that market.
Wow, okay. So they have their hands in a lot of pies.
Exactly. They aren't just selling to Meta. The financial data outlines the spending by 2026 for the other giants.
Let's hear the numbers.
Amazon Web Services is spending $200 billion. Google Cloud is spending $175 to $185 billion. Microsoft is putting down $140 to $150 billion. Oracle is in for $50 billion.
Okay, that is a very distributed risk.
Right. And every single one of these companies requires custom networking, massive server racks, and advanced optical fiber to connect their systems. Corning basically operates as the impartial arms dealer in this AI war.
Since we are talking about these companies spending literal trillions of dollars, we need to look at exactly what they are building.
Yeah.
Because the scale of these data centers is almost hard to comprehend.
Right.
The power demand alone is staggering.
Oh, the numbers are historic.
Yeah.
The sources show the power demand for these data centers jumping from 147 terawatt hours to 606 terawatt hours by 2030.
That is just insane.
It's a 22.4% compound annual growth rate. To put that in perspective, 606 terawatt hours is more electricity than the entire country of Germany uses in a year.
An entire country for data centers.
Yeah. And to handle that kind of electrical load and data flow, Corning is writing two simultaneous growth tailwinds. The analysis categorizes them as scale out and scale up.
Okay, here's where it gets really interesting.
I agree.
Because think of scale out like building a sprawling, endless suburb.
Okay, I like this analogy.
You need more computing space, so you just keep building more data centers, adding more server racks further and further out across the landscape.
Right.
You avoid overcrowding the servers by just expanding the physical footprint. It's great for reliability. If one building loses power, the wider network survives.
Exactly.
But to connect all those new buildings and racks, you need massive amounts of optical fiber. The fiber is the highway system connecting all these suburban houses.
Yes, scale out is all about horizontal expansion. But you eventually run into a physics problem with that.
Which is?
Well, when you're processing trillions of calculations per second for an AI model, the physical speed of light actually becomes your speed limit.
Right, because data has to literally travel.
Exactly. If signal has to travel down the hall or to a different building entirely to reach another server rack, that takes nanoseconds.
And in AI, that's a problem.
In the world of AI training, nanoseconds are an eternity. Distance equals latency, so you have to pursue the other strategy. Scale up.
And if scale out is the sprawling suburb, scale up is taking one of those single-family suburban lots and saying, we can't build outwards anymore, the commute is too long.
Right.
We need to build a hyper-dense 100-story skyscraper right here on this exact lot.
That's a great way to visualize it.
You are packing more GPUs and more memory into the exact same physical space to eliminate the distance the data has to travel.
Yeah.
It is all about ultra-low latency, maximum speed, and getting an immediate performance boost by cramming more power into a single unit.
But of course, that density creates a nightmare scenario for the engineers.
Oh, I bet.
To support this skyscraper of data, you have to feed it exponentially more information. So Corning recently released an AI-specific innovation to solve this, which they call the multi-core fiber solution.
Okay, what does that do?
They managed to cram 4 times the data capacity into the exact same standard 125 micron cladding footprint.
Wait, let's pause on that. You just mentioned a 125 micron cladding footprint.
I did, yeah.
What exactly is cladding, and why does that specific size matter so much?
Okay, so think of an optical fiber like a microscopic pipe. The core is the hollow part in the center where the light actually travels.
Got it.
The cladding is the solid glass wall of the pipe that wraps around that core. It reflects the light inward, keeping it trapped inside so it doesn't leak out.
Oh, okay, that makes sense.
And for decades, the global standard thickness for that entire pipe that's the cladding footprint has been 125 microns, which is roughly the thickness of a human hair.
So every data center on Earth is already built to hold cables that are exactly 125 microns thick.
Precisely. If Corning had just made a thicker cable to carry more data, nobody would buy it.
Because they'd have to retrofit everything.
Right. They would have to rip out all their existing infrastructure to make it fit. So instead, Corning's engineers figured out how to put 4 distinct light-carrying cores inside that exact same 125-micron hair-thin pipe.
Wow.
They quadrupled the highway capacity without widening the road.
That is just incredible engineering. But if we go back to the skyscraper analogy,
Yeah.
if you suddenly have a 100-story high-rise packed with people where a single family used to live, the elevator is going to break down. You're going to have a massive traffic jam in the lobby.
Oh, absolutely. And in a computer chip, that traffic jam generates heat.
Oh.
Massive localized heat. I mean, if you've ever played a heavy, graphically intense game on your smartphone and felt the back of the device get uncomfortably hot against your hand.
Yeah, we've all been there.
Imagine scaling that heat up by 1 billion. When you pack hundreds of blazing fast AI GPUs closer and closer together to reduce latency, you create a literal thermal crisis inside the microchip itself.
Which means the fiber optic cables connecting the buildings aren't the primary bottleneck anymore.
Exactly.
The heat inside the chip is. We have to figure out how to fix the chip. And that brings us directly to our second technical source.
Yes, moving from the macro to the micro.
Right, we are moving from the macro, the massive data centers and miles of fiber optic highways, down to the microscopic level of advanced semiconductor packaging.
Because fiber optics aren't enough anymore.
No, we need glass inside the chip itself.
And this is where we introduce TGV technology.
Through glass via.
Right, through glass via. To understand why this is a revolution, we have to look at how microchips are built today. Historically, the base layers that connect different parts of a microchip together, which are called interposers, have been made of silicon.
So why on earth are engineers suddenly trying to replace silicon with glass?
Well, the engineering text outlines 2 primary advantages of glass over silicon: high-frequency transmission and excellent insulation.
Okay.
Because we are moving into an era of 2.5D and 3D advanced packaging.
Let's define that for the listener really quick.
Good idea.
2.5D packaging is where you place different silicon chips side by side on that foundational interposer layer so they can talk to each other.
Right.
And 3D packaging is when you take those chips and literally stack them vertically on top of each other, almost like pancakes, to save space.
Exactly. And as AI demands higher and higher electrical speeds to communicate between those stacked chips, the electrical signals traveling through a silicon base start to interfere with each other.
Why is that?
Because silicon is a semiconductor. By its very nature, it can leak electrical signals at ultra-high frequencies.
Oh, I see.
The signals bleed into each other, causing data corruption and throttling the speeds. Glass, however, is a fantastic insulator.
It doesn't leak.
Right, it does not leak electricity. It keeps those high-frequency signals perfectly clean and incredibly fast, even when the chips are stacked directly on top of each other.
So what does this all mean for the actual hardware? Because I have to ask a really grounded, practical question here about the physics of glass.
I'm ready.
I am not a material scientist, but I know what happens when I take a cold glass cup out of my kitchen cabinet and pour boiling water into it.
It shatters.
It violently shatters. It cracks because of the sudden temperature change.
Yeah.
If we are packing these blazing hot AI GPUs closer together in a 3D stack, and we are using microscopic layers of glass as the foundation, aren't we just asking this glass to crack under the intense thermal pressure of the servers?
What's fascinating here is that your kitchen tub analogy is the exact bottleneck the engineering text identifies for the entire semiconductor industry.
Really?
Yes. It cites severe process yield issues, package mechanical strength, and the ultimate villain, which they call material thermal mismatch.
Material thermal mismatch.
Yes. So inside a microchip, you have metal wiring running through the glass.
Okay.
When the chip heats up to extreme temperatures, metal expands at a completely different rate than glass does.
Ah, I see where this is going.
Right. The metal swells up, but the glass stays rigid. That mismatch in expansion causes intense internal stress, warping, and ultimately microscopic cracking.
Which ruins the chip.
Exactly. Right now, this thermal mismatch is severely slowing down the mass production and reliability validation of next-generation AI chips. Everyone knows glass is the answer, but nobody can keep it from breaking.
Which is exactly why hyperscalers are turning to a legacy company like Corning.
Full circle.
Let's think back to their history from our first source. We aren't just talking about a company that makes pretty windows,
No.
who mastered heat-resistant ceramics that can survive the inside of a burning automotive emissions engine,
Corning.
who spent a decade engineering Gorilla Glass to survive massive mechanical stress, bending and dropping on concrete without shatter.
Corning did.
They have spent 170 years doing nothing but manipulating the thermal and mechanical properties of silica and glass.
It's what they do.
They are uniquely positioned in the global market to solve this thermal mismatch at a microscopic level.
Yeah.
It's not just about making glass clear so light can pass through it. It's about engineering glass at a molecular level,
Yeah.
so it expands and contracts at the exact same rate as the metal wiring inside the chip.
So it survives the extreme thermal duress without warping.
Exactly. The synergy here is kind of mind-blowing. The tech giants are funding the massive fiber optic scale-out expansion because they desperately need the cables today.
Right. They need the highways now.
That gives Corning billions in guaranteed upfront revenue. And Corning takes that secure financial foundation and uses their massive R&D budget to solve the microscopic scale-up problem.
The TGV thermal mismatch.
Right, which will literally unlock the physical constraints of the next generation of AI chips tomorrow.
It is an incredibly robust business model that basically feeds itself.
So let's pull all these threads together and step back to look at what this means for you listening.
Yeah, let's recap.
We started this deep dive with a guy blowing glass in a soot-stained workshop for Thomas Edison in 1879.
A long time ago.
We traced how that relentless dedication to R&D turned them into an infrastructure chameleon, allowing them to quietly become the physical backbone of the dot-com boom, the smartphone era, and now the AI revolution.
Right.
We looked at how they eliminate financial risk by forcing tech giants like Meta to pay upfront for colossal expansions, like that new facility in Hickory, North Carolina.
And we explored the physical reality of the data center boom.
Mm-hmm.
We broke down the sprawling suburbs of scale-out fiber optics and the dense heat-generating skyscrapers of scale-up GPU clusters.
Which finally led us down into the microscopic architecture of the computer chips themselves.
Right, where the future speed of AI entirely relies on through glass via technology surviving the immense heat of 3D chip packaging.
Looking back at the financial analysis from our sources, their conclusion feels incredibly grounded now. The analysts issued a buy recommendation for the stock.
They did.
At the time of the report, the current price was $128.55, and their base price target was $158.02.
Which is a solid jump.
That represents a 22.9% base upside. They anchor that entire bullish outlook on what they call Corning's fundamentally de-risked platform.
Right.
Now, as always, a quick reminder to you, we are analyzing a specific historical investment thesis from our provided sources today. We are not offering personalized financial advice for your portfolio.
Absolutely, not financial advice.
Yeah.
But, regardless of where the stock price goes, there's a profound takeaway here about the nature of our modern technology.
What's that?
We constantly talk about artificial intelligence as this highly advanced, ethereal software phenomenon. We treat it like a detached cloud of algorithms and code floating above us.
We really do.
But ultimately, the limit of human artificial intelligence isn't bound by the code itself. The algorithms are ready. The software is eager to run faster and process more data.
So what is the limit physically?
The true limit of AI right now is bound by our physical ability to manipulate one of humanity's oldest, most primitive materials, silica and glass at a microscopic level without it melting or breaking under the strain.
Wow.
We are pushing the absolute boundaries of physics just to let the software do its job.
The software might be writing the future, but it's the glass that has to hold it all together.
Exactly.
Thank you so much for joining us on this deep dive. The next time you pick up your phone, take a second to look at the glass on that screen with just a little more reverence.
It deserves it.
It is the exact same material holding up the entire future of the internet. Take care, and we will catch you on the next one.